Uh, Agus, would you mind disabling your share for a few minutes? I'm going to do a few slides and then hand it over to you.
Okay.
Thank you. So welcome, everyone. This is the Quant University AI Fall School. It's been a while since we have done this. We took a break in the summer, and we are back. It's my immense pleasure to host Dr. Agus Sudjianto today. I know Agus is always working on the cutting-edge projects, and I'm always excited to see all the amazing stuff he's been working on. So today we are going to have a power-packed, information-packed session with Agus, and we are going to have a few minutes of Q&A at the end of today's session. So if you are joining in for the first time, we are Quant University. We basically focus on education, and we are based out of Boston, Massachusetts. So let me see if I can share my slides in here. This is the first guest lecture in the 2024 fall series. We started Quant University 10 years ago, primarily focused on the intersection of data science, machine learning, and finance. And we work with large financial institutions, primarily assisting them, helping them with frontier projects on how to enable various technologies which are out there, and then how to bring it and contextualize it in the business practice. As you know, finance has been in the cutting edge in terms of adopting AI and machine learning technologies. And we are seeing a whole influx of new technologies, especially with all the innovations in generative AI. And we are hosting 3 classes, one in October, primarily focused on AI fundamentals. In November, there's going to be a session on generative AI, ChatGPT, and financial applications. And in December, we are going to have a bunch of case studies and use cases, primarily geared towards financial professionals. And if you're interested in joining our formal school, these are 3 full-day classes held in Boston in person and also streamed online in a hybrid mode. So if you're interested, please email us at info@qsandbox.com, or you can go to the Quant University website where you can find in more details. Now, we also are going to be doing a series of guest lectures, which are going to happen every week over the next 12 to 14 weeks. Next week, we're going to have Jacob Kosoff from Bank of America, and he's going to be talking about his experience on the use and governance of generative AI in large US financial institutions. So if you're interested, please dial in at 12 o'clock, either on LinkedIn, or you can access the Zoom session. We'll share that on social media and also on our Quant University website. And we also have a couple of other new programs coming up. If you are in the Boston area, or if you're interested in joining online, on October 18th, we have a half-a-day session we are hosting in Boston, primarily for the Boston FinTech Week. And we have 2 sessions. We have Cleta from Glasswing Ventures, Anish from Fidelity, Dushyant from Rosenblatt Securities, and Arun Verma, who heads quantitative research at Bloomberg. So we're going to have a power-packed AI and investing session in the morning, and then we're going to have a masterclass. And this is a complimentary free masterclass. You can just join in either over Zoom or in person in Boston. It's going to be at the Babson College in the South Station area in the Boston area. So if you're interested, here's the QR code and also the link so you can dial in for a half-a-day session. And if you are in the Boston area, I'd love to kind of meet you in person. And before I hand it over the stage to Agus, I'd like to mention that we have speakers from State Street, from TD Bank, and from NIST, and many other organizations who are going to be joining us for guest lecture series for the next 12 to 14 weeks. So if you're interested in, mark your calendars. Every Tuesday at 12 o'clock, you're going to have one information-packed session. And if you're interested to know and get more formal invites, please join us on our LinkedIn and also our group on our mailing list so that you can get information about it. Without further ado, I'm going to hand over the stage to Dr. Agus Sudjianto. Agus is no stranger to the quantitative modeling world. So he has been working on quantitative models for many, many years. And with the innovations in AI and machine learning, he has been in the forefront in not only setting up the stage for professionals and in the financial industry on how formal validation needs to be done, but also creating infrastructure and tooling to ensure that people are leveraging all these tools in a responsible way. In his prior role at Wells Fargo, he actually pioneered a lot of cool tools. And in fact, we have had many sessions with Agus. He's been gracious enough to give his time and also a lot of information. He's bestowing all these assets to us in terms of information nuggets through PiML and all these cool tools. But in his latest role, heading up risk and analytics at H2O, he's been pioneering how to validate and test generative AI models, which has been the talk of the industry today. So I'm very pleased to invite you back, Agus. Welcome back from your retirement, your post-retirement, but also on your next rung of innovation, if you will. And I would love to kind of hear from you on what you've been working on, and we'll use the last 10 minutes for Q&A. If you're interested in asking any questions to Agus, please put that in the chat window or in the question and answer panel, and we'll use that in the last 10 minutes to answer any questions. So please take it away, Agus.
All right. Thank you so much. Hello, everybody. So Sri, thank you for the opportunity. It's a pleasure here to present this, and feel free to raise any questions. So a little bit background. So Sri mentioned about my retirement early of this year as the head of model risk management for Wells Fargo. Now I can spend my time focusing on technical side. Many of you probably familiar. If not, check it out. I released PiML, Python Interpretable Machine Learning, about more than almost 3 years now. That's the tool that are used to develop and to validate predictive machine learning, to make sure that it's inherently interpretable, sophisticated, inherently interpretable, and do all kind of testing, reliability, robustness, and so on and so forth. The reason I mentioned that is because the philosophy that we put in PiML are carry over to the philosophy when dealing carried over when we're dealing with the GenAI. The techniques, the testing will be different, but the principle will be very, very similar. So I am going to go through that a little bit. So let me share my screen, so that we can start. So today I am focusing in model validation, particularly on the GenAI and LLM. This is joint work with my co-developer, Srinivas Depali. She's the software engineer at H2O who developed the tool together with me. And Tarun Joshi. Tarun Joshi is the head of model validation for NLP and GenAI at Wells Fargo. So we're working together, building the approach and the software together, and the tool and the library. So let me start with this. This is my view about AI. AI is a guessing machine, so it's predict the next token, no more than that. So AI is a guessing machine, but it's very, very powerful when you train it with such a big data, with very, very large model. It has very interesting result, right? It's very powerful, but can be unreliable. Very useful for use cases with low risk downside. You want to create a background of PowerPoint slide and things like that, that's fine. But now we want to use them for cases where mistake can cause real harm, like in the finance and medicine. Now, if we're dealing with such unreliable machinery, what can we do? Well, we know these tools are very useful, very powerful, but now let's do it in a way that it can be, we have confidence and safe and sound. So some of you that familiar with model validation, and some of you that don't, probably need to review some of the things, lesson learned from model risk management in industry. It has 3 components when we talk about model validation. We talk about conceptual soundness, make sure that the model is sound, makes sense. Outcome analysis, how we test it, testing beyond just performance. So I came from a background of product design. Early on my career, I designed car engine for Ford Motor Company for 10 plus years. So we always not only thinking about when we talk about engine, we're not only talking about horsepower and torque. We also talk about durability. We talk about fuel economy. We talk about noise, vibration, harshness. We talk about all many different things, right? So it's not only performance. So when we build a classifier, it's not only NUC, but it's all talk about many different things. So outcome analysis is really the key is the point in there in the outcome analysis is identification of model weakness, how the model will fail, because all model will fail, and you will see it here. It's particularly GenAI fail very, very easily. So outcome, and then ongoing monitoring. Once you deploy, now how you continue monitoring and testing, etc. Now the challenge is this. This is very tedious and labor intensive. In predictive AI, at least we have data and we can test it with the data. In GenAI, testing, we have to create, we have to generate the testing. It needs probably manual labeling. So tedious and labor intensive. The second thing, because of tedious and labor intensive, how can we make sure that the test is comprehensive? We test everything, right? Comprehensive testing. That is a very, very tall order. And then we talk about multiple imperfect metrics. We talk about how are we going to measure it? Well, let me give an example. If you want to use GenAI for summarization, we're going to measure the quality of summarization. What do you mean by quality of summarization? Is it conciseness? Count the number of words? Is it how coherent the summary is? So you have to measure coherent. Is it grounded, not hallucinating? Okay, so you have to measure the hallucination. Is it complete? The summary is summarizing completely the context that are given, right? So it's so many different things. That's only talking about summarization, let alone talk many other things. So we have to deal with multiple metrics, and none of them are perfect. And then if you have to do human evaluation, that's even more expensive. So this is a very, very challenging situation. Now, I talk about conceptual soundness, data quality, and suitability. This is something that is forgotten in the world of GenAI because you just download any data from the internet, right? Input, design, and control. In predictive AI, we have to control what are variables we're going to use, the feature engineering, the feature selection, and the controlled range when the model in production. So we have to think about this as well. Explainability and interpretability. How the relationship between input and output, we need to understand it. So that's a very, very important, including in GenAI as well. And then, of course, optimization and benchmarking with other technique. I talk about conceptual, about outcome analysis, model weakness identification. I talk about that. Talk about reliability, uncertainty of the model output. Talk about robustness. When your prompt changes a little bit, is the answer going to be very, very different. That's robustness. Talk about resilience, how if the user drift, the user difference, and etc. Then also, of course, we talk about the business alignment, talk about toxicity, fairness, etc. So if you talk about comprehensive validation of LLM, it's hard, and I would call it impossible, because the data that used to build LLM is infinite, right? All the data in the internet. And then during the usage, no control of model input. It can be anything. All goes and everything goes in the on the input, on the prompt. All possibility. Because of that, the output is all possibility. So validating comprehensively LLM is hard and is impossible. So yes, people do benchmark and all of those things, but it's so limited. So comprehensive validation is hard as impossible. But comprehensive validation of RAG is possible. RAG, I hope some of you understand RAG, retrieval augmented generation, is possible. The way I look at RAG is, yes, people use RAG to make it more grounded, using the information, all this thing, but from model risk point of view, we bound it with RAG, meaning that we only going to answer question within the boundary of this document that is in RAG. So, and those are finite. Let's say 500 document or 1,000 document in our RAG system. So it's finite. Now, because it's finite, we can test all of those. We can test it comprehensively. And we only allow prompt that relevant to the content in the document and limited range of output. So that's what I'm going to talk about. We're going to test RAG. If we want to talk about validation, validation has to be for specific business use, and we can test it. I'm going to skip RAG because I'm going to assume all of you now. I'm going to skip all of this, the sentence embedding. I'm going to assume all of you know this. If it's not, then that's the chance for Sri to teach people about GPT and sentence embedding and all those things. I'm going to skip all of this. The focus of model validation is validation of LLM system for specific business purpose, not generic LLM. If you ask me, well, there is a bunch of benchmark out there. Benchmark out there, yeah, it's interesting, but it's completely useless for real business application because we have to test it for specific purpose. Now, we have to be able to, for specific purpose, we have to test it comprehensively. Coverage. If I have 1,000 documents, I need to test it for all the content in all those 1,000 documents. This is clearly, we have to make the testing scalable and through automated testing. So that's what we're going to talk about through automated testing. And the metrics that we need to use is the metric that's very transparent and explainable evaluation metric. We do not use LLM as judge or jury. If you're in a regulated industry, you want to use LLM as judge and jury, I would say good luck, because you will be challenged about who validated the jury, how, from conceptual soundness point of view, how are you going to justify that next token generation and use it as a jury, which is as a classifier? So it's a very, very hard to do that. Plus, it's opaque. Whatever the decision that LLM does, that's the decision that LLM does. You will not know how the decisions are being made. So that's a problem there. So LLM is judge, LLM is jury. People, a lot of thousands of papers talk about this, but it's completely useless in my opinion, at least for now, right? Until we can trust the machine to be as a judge. So we need techniques, we need metrics that is very transparent, explainable, easy to understand, which we're going to do that a little bit later, okay? And then the fourth component is because we are doing automated evaluation, test cases will be automatically generated and will be algorithmically calculated in terms of evaluation metric. We need human sampling to do verification and calibration. So machine calculation will be calibrated to human labeling with small sample size. So that's what we are talking about. And then the key that I'm going to present today in the model validation is really identification of model weakness and diagnostic with explainable diagnostic. So model weakness is the center, is the cornerstone of model validation. Understanding the weakness of the model so we know what to do with it, we know how to deal with it. All right, so this is the workflow that I'm going to go through, and piece by piece, I'm going to look at a few components. One is we start with step number one, Q&A pair curation. We need to do, remember, we have document are being chunked. It has content document. We're going to test all of the creating question and answer that will be able to be answered by those documents. So we have to do statistical sampling, get coverage in the entire space. So let me give an illustration on that, okay? So every point here is a chunk, okay? The document get sliced into chunks, okay? For each of these are chunk and chunk are embedded, right? In a high dimensional factor representation. That's what we call as embedding. So, with the high dimensional embedding, we are going to say, we're going to make sure that we're going to test everything. If we ask people to do manual testing, they're going to test very few sporadically somewhere, right? But if this is your entire document, we need to really test the entire thing. So how we do it? So we do stratified sampling. So first of all, we do topic clustering, right? We do the topic modeling. So we know how many topics represent in your entire space of document. From that topic, then we say, okay, we're going to sample within that topic. We're going to sample, okay? So the step that I do, and I do dimensional reduction here for visualization. So if we have, let's say, we have 1024 embedding or 2048 embedding, that's very high dimensional things, right? The first things first in the data science, we all say if you want to do clustering, we don't cluster that with the high dimensional space, because then the cluster result will be terrible. So what people do in the tabular data, people will always do dimensional reduction first, like principal component, and then they do clustering in the reduced dimension, right? So that you can get a better clustering. So it's the same thing. We do dimensional reduction first. You can use many different techniques. We can use UMAP. We can use a random projection, many different techniques for dimensional reduction that you can apply. Then you do clustering based on the reduced dimension, so that redundant information not double counted, right? That's the key on dimensional reduction, is really to make the not double counting redundant information. Then you do topic clustering. Each area become a topic. You can use language model to extract the you basically do TF-IDF and send it as a topic summarization to make it more interpretable. So and plot it into D. In this case, we plot it into D so that we can understand what's going on. What is in the mind of LLM, right? What is in the mind of embedding model? So this is very, very simple and handy things to do interpretability by plotting it in low dimensional space. It's similar to tabular data. We do that all the time too. In tabular data, we plot it, effect plot in low dimensional space. And in tabular data, the number has ordering, has all of those. In language, we don't. So we do clustering so that we can categorize. So that's very, very handy for interpretability, to understand what the embedding really capture in terms of topics and all of those things. The reason we do topic, because it's human friendly, right? Interpretable. So then you sample it. After you sample it, then you need to generate question. If you say, okay, I'm going to be a little bit sophisticated, I'm going to do multi-hopping things. If I have question, need to be answered by 3 different chunks and through conclusion. So we can do summarization first. Claim, extract the claim in that summary, and then for each claim, convert it into question, right? So we know what the answer should be, what document should become a context. We generate, so we reverse it. We generate questions. So we generate questionnaire. We use LLM to generate question. Once you generate question and a family of question or series of question or a set of question, you have to check the quality, whether they are good question or not. And if you do it manually, it will be too laborious. So we can do quality self-check using relevancy metrics, which we're going to talk about a little bit. So the point here is basically, I am going to test it in the entire space. And I'm going to sample it using stratified sampling, using twinning techniques and all of those things, so that my sample will be representative in the entire space. This is important because we want to make sure that we understand the edge cases, rare cases, where model will fail, right? So if we don't do this, then our test will not be comprehensive. So we need to cover the entire space on the testing and generate question and answer pair. So I have my first step. I have the question and answer pair that I generated. Now, from this question and answer pair, now we need to evaluate. Right? So we have question and answer pair. We have the question get generated. Now let's feed it to let's test our RAG system or test our summarization system using this series of questions, which can be it can be 1,000 questions or it can be 10,000 questions, right? This it's up to the test design, right? So we're going to run this through that then question 1,000 question or 10,000 question and see how good the system is, how good the model is, and if they have problem, what kind of problem that we're going to have, right? So that's what we're going to do. Now, let me go back a little bit. So when we test RAG system, many of you know this thing. So you have prompt. So I have to retrieve the information, retrieve the context. So you have to measure it. How you measure it? I can measure the recall. Do I get the information that I'm supposed to get? Right? That's recall. Precision. Do I get all the information only information that's meaningful, not any just other information, because that's precision. Measuring relevant information. So measuring and then measuring the relevancy. How relevant is the document? So this is first is we want to measure the retrieval capability of this RAG. And this is interesting because a lot of people just, okay, RAG will do it. Well, there's a lot of problem with RAG. Just even retrieval, it failed to retrieve, and I'll show you a little bit later. So we're going to measure recall, precision, relevancy. So that's the first step. Once we have the context, okay, that's recall, precision, relevancy is really the problem. If we have problem, it's the problem with the embedding model and the problem with the chunking system that you have, right? So we need to measure this so that we can diagnose, do I have a good chunking strategy? Do I have a good embedding model? So that, and do I have a good matching or search or whatever techniques that we do? Because today, RAG probably has a lot of variation, not only based on semantic, but you can also based on lexical and all of those things. But at the end of the day, we can measure whatever things that you wanna recall here. Now, once we have the context, now we're going to test the LLM, because given this context, we give this context as LLM to summarize it, right? To provide the answer, to summarize it, or to provide conclusion, or whatever you command your LLM to do, you get the answer. Now, if you get the answer here, the question is this answer grounded to the context? Is this question not having any component that LLM completely makes things up? Because it's very easy. LLM will make things up all the time, okay? So we need to measure the groundedness, how grounded the answer to the context that we gave, right? And then at the end, we also need to measure answer relevancy. If I have prompt, I retrieve, I summarize it, is it really answering my question, right? So that's answer relevancy. So all this step is what we're going to measure in our RAG system. All right, so how is the model validation approach? How are we going to test this model validation? First is we're going to validate it, what I call it a black box approach. I don't care about the LLM and the system. I'm not going to understand my nitty-gritty detail what's inside it. We're going to treat it as a black box. But system, if impossible, we want to decompose it so that we can diagnose where the problem is. In RAG system, I mentioned before, I'm going to test the retrieval, okay? Is it embedding problem? Is it chunking problem? And all those things. So I'm going to test the retrieval, and I'm also test the generation system, right? So you decompose it so you can diagnose and attribute where the problem is. And then analysis and evaluation will be facilitated by what I call it surrogate model. We are using another embedding model to explain and to diagnose the capability of your RAG system. So all the measurement metric will be computed with embedding model. Remember before I said, we're not going to use the language model as a judge. We're not going to use all of those, but we're going to use calculation that's very transparent, very simple, very easy. So that's what we're going to do. And then we have human evaluation at the end. Okay, I'm going to skip on this. Key evaluation metric, right? I talk about recall, precision, relevancy, groundedness. Talk about ability to answer is aligned with relevant context. I talk about that and answer relevancy. So I already talked about this. Now, the key here is we are going to use metrics that very simple, very understandable, based on semantic similarity and semantic similarity only, because that is very easy things to do. So we're going to use simple metrics, be it through semantic similarity or natural language inference, which you can look at the embedding as well. At the end of the day, everything is all about embedding. When we talk about language model, when we talk about neural network, everything is about embedding. Understanding the embedding is the key. And embedding, we can visualize it, we can understand it. Okay, I'm going to skip the math on that. I'm going to go to the math a little bit on the next one. This is just a simple illustration. Remember precision and recall, and also remember topic modeling, right? So we're going to evaluate for each topic. How good is this model for each topic? How fluent is this model for each topic? So on the left here is the recall. Recall 1 means that you really get the information. When recall 0, you don't get the information at all. So you see here a lot of things that the direct system not able to get the information that needed. And if you look at in this example, the context precision is so low, very low, because in this example, the direct system just retrieving a lot of information and then pass it to the LLM, right? You retrieve too many information, a lot of useless information. That's why you retrieve your precision is low. People sometimes do top K or top 20 or whatever, but it's really because in this situation, the precision is so low, the direct system, the retrieval system retrieves so many information. When retrieve so many information, then you have to rely on the LLM to provide good summary. Now, if you give a lot of context, the summary will be all over the place, including summarizing information that's irrelevant, right? So that's what you don't want to happen. So having context, good context that you retrieve and you summarize and then you send it to LLM will make LLM better because it's focused instead of doing all over the place. Okay, so in the let me just go to relevancy. This is a very simple measure. Okay, I'm going to do sentence recall and sentence precision. If I have query and I have chunk, and I can break the chunk into sentences, okay, or into main idea, whatever you pick some trick that you want to do. Let's say the simplest thing, I'm going to break it into sentence. Then I'm going to match sentence per sentence between my query and then the chunk that I retrieve. I'm looking at similarity. And I calculate the maximum similarity. Maximum similarity means, yeah, I found information in the context that most relevant to the query, right? So that's max. So the higher the max is the better, right? Meaning, hey, I found the information. The lower the max value mean I'm retrieving something that not relevant to the question. Again, this is based on the embedding, sentence per sentence. And we do it sentence per sentence instead of I have the entire query and the entire chunk. I do it sentence per sentence. Why? Because embedding sentence, the embedding model typically train as sentence embedding. They train by sentence. If you have chunk that's a long sentences, a lot of sentences, the embedding will be very different. Your RAG most likely will fail when you try to match it with the short sentence. So we do it by matching to find the max, to find the most relevant information, right? So when you run it, then you can get for each topic, It's able to retrieve information that are relevant, but also information that is irrelevant. Every point here, by the way, is the query that we generated before, right? So you can look at it how the model perform in for different topic, okay, in terms of recall and relevancy. So that you say, okay, there's some area, some topic, the model not very good because they have long tail on the left. Right, so the result is not very good, retrieving information that's not very relevant, very meaningful. So this is so we can use embedding, sentence embedding, to measure how good is your retrieval. Then groundedness, we can do something similar on the groundedness, right? Is the information grounded? So now I'm looking at the sentence in the chunk. Now this is between chunk and the out. Now we're talking about chunk, context, and the output of LLM, something that can summarize to LLM. Now I'm looking at the LLM output generated by LLM to see sentence per sentence, compare it to the chunk, to find any sentence in the output of LLM that's far away from the context. The more far away from the context, the less similar, right? So your similarity score will be lower. That means that's more hallucinating because it's far away from your context. So if you do that, you can see a few, this is a few example, and in that, so we based on semantic similarity, we can measure how grounded the model is, how grounded the output to the context. So again, every point is a question that get generated before, that we generated before, and so we can look at it. In some topic, it says very long tail, where the model clearly hallucinating, make things up, right? So it has hallucination component, make things up. So make up there's something that's not in the context. That's something that we don't want. So, and then we look at answer relevancy. It's the same thing. Now we're looking at the embedding of the query and the final answer and how relevant they are. And you see the long tail. Yeah, the LLM give answer, but answer that's not relevant. Okay, and we can see which topic, the weakness of the model, and what topic that the model is weaker than the other. Okay, now we have all of these. The decision become, if this is groundedness, this is all are done in very algorithmic way, no human in the loop. Now let's put human as the final judge. Now we're going to sample it. Let's take 5% sample from the test, from the big test, and ask human to rate it now. Okay, ask human to rate based on 5% sample of the total sample that we have. That's just an example. The human will label it hallucinating, not hallucinating, and things like that. Then we can do calibration. We can calibrate between this algorithmic measurement versus human measurement. So it's very easy to do. First is you can do logistic regression. I can create logistic regression between any measure to human labeling, right? So we can calibrate between the two using logistic regression to calibrate. If it's the human give rating, then you probably want to do ordinal regression or something like that. Okay, but basically you use simple regression model to do calibration, and then you can apply conformal prediction set so that we can say, okay, I'm going to do 90% confidence how the machine is making decision. So if we do that, so we do, as I said, do random sample from machine evaluation, do a human labeling, fit logistic regression, compute conformal prediction on sample set, and apply the result to overall sample, right? And set threshold value for doubtful for further investigation, further labeling, or if you want to put in production, you can put it as a guardrail. Let me give an example on this. So I have a human calibration, remember, and I fit the logistic regression, right? On the right here, it's not hallucinating. On the left, it's hallucinating. And then you can see the threshold here. On the left here, the threshold here about 0.61, definitely hallucinating. 0.64 and above, definitely not hallucinating. Anything in between is it's unknown. This is what conformal prediction will give you. Give a prediction set so that, okay, now I know that 0.64 and above of my score is good, not hallucinating. So then you apply all this conformal prediction calibration to your entire data set, entire testing. In this case, I have another 600 something tests, right? That I have that I did not label because I only labeled 70 of them. Then we show, okay, I have the empty set are 33. Sometime in the middle here are about 33 sample. That's a sample that you probably human need to evaluate it further to see why is the it's human calibration get confused in that side, either the human confusion or it's really the machine calculation. It's that's not good. But we can do basically simple calibration that we can do. And from that, then we can say, okay, now how are we going to deploy it? Well, we're going to deploy with high performance, trustworthy, reliable output. Then you apply the threshold. So when your X system produce something, you can calculate the probability, right? Probability of groundedness with high probability or with the score and high probability, and then you give the answer. If not, then you say, okay, you have to redo it, do a instead of single shot, you do iteration. If it's result not good, then just say, oh, okay, this one we cannot answer. So I am going to stop right there first so that we can have question and answer on this. I went through really super fast, but I hope you get the gist, the idea, what this one is. Sri?
Yeah, thank you so much, Agus. This was such an information-packed session. So I gotta spend the next week trying to decipher each one of these. And thanks for putting all the content and also all the thought behind all these processes. So we do have a couple of questions. So I just want to bring that up before I have I'm gonna have some of my questions. So people who are listening in, if you have any questions for Agus, please type it in the Q&A window so we can bring those questions up. So one question Sumanta Das has is, could you explain a little more about the surrogate model you mentioned?
Yeah. Remember, we have to measure, we have to calculate. 1 second. We have to calculate all of this, right? We have to calculate all these metrics, yeah, with semantic similarity, right? We have to calculate all of this based on semantic similarity, based on embedding. So we have to choose an embedding model that we want to use, okay? We're going to pick an embedding model that we're going to use to calculate all of these, because all the relevancy and things like that based on the embedding model. Now, how good your embedding model? If your embedding model not good, then the agreement with human will be less, right? If your embedding model is good, then the agreement with the human will be more. So choosing a good embedding model is important, but some of you, I hope, I'm familiar with that. I'll go to that a little bit on this. I have it in my slide before. Embedding model is very simple, right? The trained embedding model is you pick what embedding model, and typically embedding model train using contrastive learning, right? Using Siamese network kind. So I have sentence A, I have sentence B, go to a transformer, you get the embedding A and embedding B. If these two sentences are the same, they should be matched the same. Call it the same. If they are different, call it different. Or so typically you have a triplet loss function using anchor positive, negative, and to contrastive learning to distinguish similar and then dissimilar, right? So that's embedding model. So a sentence that are similar, it should be embedded similarly. Sentences that are different, it should be embedded differently. So that's the embedding. So many embedding model out there. Hugging Face, there's plenty of them. You pick embedding model that you want to use.
Perfect. Yeah, thank you, Agus. So a couple more questions. One from Amul Bhatt, actually two questions from Amul. Let's see if we can look at both. How do you review the implementation and the use of LLM with RAG components? And I'm just going to add the second question too. If it's a closed model like ChatGPT that costs money, how do you do budgeting for testing?
Well, how much? First of all, I'm talking about RAG system. Yeah, if it's a black box model, if you don't know the intermediate, basically the retrieval capability, if you cannot do retrieval information, then what typically you do, because they will say, okay, even ChatGPT give you what is the reference context, right? But you do step by step. But if you don't, then you only do the input and output, which is the query and the result, right? So you look at answer relevancy. That's all you can do. So that's what, first of all, that's what you want to measure. But we treat it as a black box. We're going to use embedding model. The input and output will be evaluated using my embedding model, whatever choice of embedding model you do, and we're going to evaluate it with that. So that's why I call it we're using surrogate model. Cost-wise, how much? Well, let me say this one. If the people have budget to deploy, which is going to have 1,000 users or whatever number of users to use it, now they have to spend money for testing, because the testing is much, much less than the actual use.
Absolutely, absolutely. And I mean, like, one of the challenges is nowadays all these big models are expecting you to like dump the whole corpus and say, hey, we'll extract information. And I mean, like, in the class I'm teaching at Northeastern, so we're also looking at how do you even like validate some of these vector databases and the stuff you put in it, right? Because you have multiple engineering components you're putting together. And then, some of these are also on the cloud. So, a lot of interesting questions. So another question from Philip Kim.
But it's the same, though. Let's say I'm not going to use RAG system, but I'm going to just use very long context, right? Right? But it's still context, right? Still context. But given this context very long, it's going to make things up.
Absolutely.
Unless it's behind the scene, you really retrieve it, finding information that's useful. That's the one that get fed, right?
Yeah, and I think it kind of leads to this other question, right, about similarity, right? So because how do you deal with semantic similarity measures when you have two sentences that are only different by one word, but that one word is the most important and completely different?
Yeah. Yes, you can. That's the thing. BERT score is word, right? I show you the sentence version, but if you look at BERT score, it's the token version, right? So you can look at token similarity.
Yeah, absolutely. So a couple of the questions. One, and I'm going to bucket these two questions in this context of what I call as feature engineering. I mean, prompt engineering is more or less feature engineering, right? Like you're putting together stuff for the model. The inputs, in the traditional sense, we are putting together features and giving it to the model. So John Mueller asks, how do you tune the chunking? How do you create chunks that have just right enough information to be represented in an embedding vector? I mean, there are a lot of chunking strategies, but in the context of validation, I would say, how do you kind of think about chunking and validating these chunking strategies too?
There are so many ways to do chunking, and it's very, I would say, situational things. Which one is better than the other, right? Depend on the document and all of those things. At the end of the day, when you do model validation, what you do is you do benchmarking. Okay, people use this chunking technique. I just going to do the chunking technique. I'm going to measure it in my retrieval, right? Remember, I show about the relevancy measurement, then really look at the quality of recall and precision, right? So at the end of the day, okay, I'm going to use a different chunking strategy, see if my distribution is better using a new chunking strategy. So that's what I will do.
Yep, absolutely.
Compare.
Another question related to prompts. How do you validate the process wherein you have when developers change the prompts, your expectation would be different. So how do you even validate this process of putting in prompts and then getting back
You mean a system prompt, I'm assuming, because the developer, right? This
in
is
the prompt
changing the
engineering
system prompt, right?
system prompts? Yeah, the prompt
Right.
engineering aspects. Yeah.
Yeah,
With
it's at the end of the day, that's it's the same thing, because system prompt is almost like a parameter in your model, right? There's so how well is that one is with that system prompt, then you evaluate it, right? So
absolutely.
you can do evaluation. This is very simple metrics that you can calculate, you can run with a different system prompt. Will you get a different result? Will you get a better result? Right?
Right, right. And I think it kind of, leads to this notion of, putting together your testing and validation sets, right? Because
Mhm.
you are expecting the human in the loop to be able to generate tests and say, hey, this is the expected answer. And then also figuring out, I'm asking my students because in the prompt engineering, when you get back the answers, you want to even constrain the answers so that you can do system validation rather than humans going and testing
Yeah.
these
Yeah.
unique use cases, right?
So let the machine create prompt for you.
Right, right, exactly. Yeah. So that kind of goes to the next question. Paul von, I presume I pronounced the name right, Paul von Hirschhausen. When creating question answers for LLM for topic or document, would I need to use the same embedding model the LLM is founded on, or can I best perform, use the best performing?
You can use any LLM, right? The process is, I'm not using embedding here. I'm using LLM. Let me go back to my slide before. You're going to get this slide, by the way, from Sri. So
Yeah.
don't worry about that. Hang on one second. Let's see.
And we are getting a lot of requests regarding the slide deck, Agus, so we should talk about it offline
Yeah,
together.
you have the slide. See, I'm using LLM to summarize and to generate question, right? To generate prompt, right? What LLM you want to use is up to you. Okay, you have your choice. Some better than the other, right? And you can instruct it in many different ways. You can do something that very simple prompt, something prompt that you can do create more reasoning, meaning that you have to make a prompt that will force question, require retrieving context and make conclusion. So many different ways that you can create prompt.
Absolutely, absolutely. So another question, I think some of these questions are kind of coming from like the traditional machine learning world and kind of bridging it to the LLM world. In your experience, Dipanjan Bandyopadhyay is asking, in your experience, are the results significantly better using GenAI versus traditional AI techniques? I think it's a
Okay, so
kind of
this is
contextualized.
my opinionated view. Yeah, what is Gen AI designed for? To generate the next token. It's not designed for doing classification.
Mm-hmm.
Yeah,
Yeah,
but a lot of people very tempting to use it as classification because it's zero shot. I don't have to build model.
right, right.
I can build sentiment analysis. I can build all this thing as a classifier. Guys, the model is not designed to build as a classifier. It's designed to generate the next prompt. If I want to do classifier, to do classification, I can use the embedding and build classifier. I can fine tune my embedding to get to be the best classifier.
Right. Yeah.
So that's my view. But sometimes, well, I don't have data. I don't have to do that. Yeah, maybe it's just a crude thing. Do it as zero shot, right? Use LLM as a classifier. But it's not designed to be a classifier. It's designed to be next token generation. If I wanted to classify, I don't need this gigantic model. I need a small embedding model that I can tune the embedding. When you plot it like this, yeah. If I have, if you have a good embedding and you have a certain topic and you see the embedding, it will see very clearly separated. If your embedding is good, right? Then you build a good classifier, right? So when you do a classifier, diagnose it. Is it good classifier or not? Your final layer in neural networks, that's your embedding. Plot it. See it. if you get a good separation, because every neural network, every supervised machine learning, final layer, final step is always linear model.
Absolutely.
Has
Yep.
to be linearly separable, right? Neural network, the final layer is a linear model. So then you can plot it, the embedding from the last layer, plot it. Do you have linearly separable problem or not? If you don't, your embedding is no good.
Yep.
So if I use LLM to do that, have you check it? Have you checked the embedding that it produce linearly separable cases, right? For the problem that you are trying to solve.
Absolutely. And it kind of, it goes to a sentiment which I've heard many times. Seems like the testing for GenAI is much more detailed, and change management is going to be an issue with so many components involved. I don't know what you're hearing in the street.
Well,
like,
the thing is this, right? We living in the new world. The model development on GenAI is not so much data science.
right.
It's technology exercise. With all the tool that we have, you're not going to train them train from scratch and all those things. It's, even if you're training, it's all technology exercise today. So it's not much data science in there. But
Absolutely.
testing it, as you can see, it's very heavy data science. Yeah, testing model is very, very heavy data science. You have to do clustering, you have to do all these things, the techniques that we talk about. It's all the calibration and all. It's all very data science. So testing is data science exercise. Building it is technology exercise.
So maybe the validators who wanted to go to the data science side are going to, come back to the validation side if they want to continue doing data science work then.
Yeah, that's what it is today. If you want to work on the developing app, that's no data science, that's technology.
Absolutely.
Right?
Yeah.
If you want to do data science, that's the testing. So it's a lot more, and the building side is becoming more commoditized. Use whatever available out there. So the trick is always, the difficult part is on the testing.
Absolutely. So I have two leading questions for you, Agus, and I know the answer, and you just shared some of the things earlier. One, is there an open source toolkit that you can put together for evaluation methods, potentially a reusable Python repo? I don't know if you're about it. Yeah.
So in the tabular data, you have PiML, right? That's what the tool I release. In this one here, a tool will be released in sometime next month, okay? Because I'm helping S2O to build this. I don't know yet at this point in time what portion will be open source, what portion will be enterprise version. So that's S2O decision.
Cool. And the other one, thanks very much for this talk. Is there a white paper that you can share regarding all these methods?
Yeah.
Yeah.
Wait for a couple of weeks. I'm releasing a white paper for predictive AI this weekend in LinkedIn. Yeah. So it'll be in archive. I give you, Sri, the preview, right, Sri?
Absolutely. Yeah.
That's the
I'm going to
tabular
read it after
data.
this session.
Yeah. The Gen AI stuff will follow soon. So stay tuned on that.
Yeah. Thank you so much, Agus. This was an absolute pleasure. And just to share one of the feedback from Debanjan, love Dr. Agus's honesty and clarity on different components. And, it's always a pleasure to have you, Agus.
Thank you so much.
And also, this is so much information packed. So we're going to share the slides, the video, and Agus is going to release some of these components, both the white paper and some of the tooling in the next few weeks. Please stay tuned for that. If you have any follow-up questions for Agus, you have Agus's contact information over LinkedIn, but also you can send it to us and we can forward it to Agus. And next week, we're going to have Jacob Kassoff, who has also spoken at the Quant University AI Fall School in prior sessions, but he came from the perspective of Region Bank earlier, but now he's at Bank of America for a while, and he's going to talk about what generative AI adoption is within a large bank context. So please stay tuned. It's going to be on October the 8th between 12 and 1. And as I mentioned before, we have many more lectures coming up at the Quant University Talks. And if you have any suggestions, or if you want to be one of the speakers at the Quant University guest lecture series, please email us and we would be happy to host you, and also please share your work so that we can bring it up and discuss in a larger community setting. It's 1:00 Eastern time, and I know most of you are getting back to your desks post-lunch. It's always a pleasure to have you all online. So we would love to see you back in the next session. And again, Agus, thank you so much, and looking forward to seeing you in person sometime in the next few months. Thank you all. Bye-bye.
Thank you.